for the success of that survey, for the success or for the effectiveness of that survey, it is important that our survey parameters must be carefully chosen. We must choose our survey parameter carefully. Why do we need to choose our survey parameter carefully? We need to choose our survey parameter carefully so that we'll be able to obtain optimum information about the target in the subsurface. If these parameters are not well chosen, then there may be need for us to go back again and again for that data collection. So it is very essential that before we embark on any geophysical survey, Samuel, can you mute yourself, please? So we are looking at optimum line configuration, and for us to achieve optimum line configuration, we need to talk about the survey design, or what we call the design parameter we use in prospecting. So one of the most important aspects of a geophysical survey is the design of the survey. And there are some certain things that will guide the design of the survey. One of those things we are going to be looking at is what is the purpose why we want to carry out that survey. You are going to be learning from other lecturers the different types of geophysical tools we use for subsurface investigation. Depending on what we want to obtain in the subsurface, that will inform the kind of geophysical tool that we are going to. So one of the most important aspects of a geophysical survey is the design of the survey. We need to have a proper design of the survey. And if you look at the image on the right, that is a typical example of when we know the purpose or the aim why we want to carry out a survey. We are going to design the survey in such a manner that what we want to get from the subsurface we obtain optimum or adequate information about it. For instance, a pipe is buried in the subsurface, and that pipe in diameter is not more than maybe 3 meters or 30 meters. That is the size of the pipe. If the pipe is 30 meters and buried in the subsurface, and we want to map it, for instance, a filling station. A filling station has been existing in a place, maybe for a reason or another, that place is needed for other developments. Before other is there, a geophysical survey is required, buried, and how big or otherwise is the tank. That current that is driven into the ground is an artificially generated current because we make use of a battery. The current that we inject into the ground will now interact with a natural current in the ground. That natural current in the ground is called telluric current. It is naturally occurring in the ground. The interaction between these currents will produce potential. 2 points. We need to measure that potential at 2 points. When the potential at 2 points are measured, we now remember our physics, Ohm's law, that V is equal to IR. Since we also know the current that is flowing into the ground, we can impedance activity will give us resistivity. That is a physical parameter that a geophysicist measure in the subsurface that will enable us now to talk about that pipe or that tank that is buried in the ground. So if we are now going to put those electrodes in the ground, when we are going to put the electrode in the ground, the spacing between the electrode is very essential. We said the tank is about 30 meters. If we now start using spacing of about 1,000 meters or 1 kilometer, we want to map an object of 30 meters, and we are using separation of 1 kilometer. There is going to be a problem. We are not going to see that tank. And in reality, that tank exists. The tank exists in the ground. Because we have used a wrong separation, we are not going to see that tank. At the end of our survey, we conclude that there is that place. And when they now go and start developing the place or the site, after some times, the building may collapse and they will call us again, if at all they will do. Why has this building collapsed? So there is need for us to carry out, or for us to know how to choose our survey parameter very carefully, very, very carefully. And that is why in the material, in planning geophysical survey, an acceptable survey design should ensure acquisition of those data that best resolve the object in the subsurface. Again, when we are carrying out geophysical survey, an acceptance or for us to design survey parameters that will acquisition of those data. In this case now, I said electrical conductivity and electrical resistivity, that of the subsurface feature or parameter of interest is very necessary. So it is very necessary that we choose, or we must select, adequate survey parameter. It is so important because no amount of data processing or analyzing, no amount of data that we are processing or that we are analyzing can ever compensate for inadequate or missing data. What does that mean? If we do not design our parameters carefully and we embark on survey and we now collect data that are not adequate, or data that information that we actually need is now missing in the data, we have to go back again. For instance, while I was doing my PhD, a colleague of mine of blessed memory now, we traveled about 8 hours to go and collect his data. 8 hours. 8 hours is like driving from Lagos to some northern part of Nigeria. But that place, if we are to do that, it can take a whole day because of the bad road we have in Nigeria. But over there, the road is smooth and all that, you drive with pleasure. And over there, once you drive 2 hours, you need to refresh yourself. You relax, you eat, you do all sorts of things before you continue back on the journey. We now arrive at the place where we are to collect the data. We collected the data for 1 week, for 2 weeks. We came back. We have to plan again after a month. And for him, the data that we have collected, he was just keeping them. He did not do anything to them, because whenever you are doing a research, you always have 3 folds of exercise. In the first fold is what we call geophysical data capturing. You collect data. That is the first phase. The second phase is data processing. You are going to process the data. The third stage is how you are going to interpret the data. These are the 3 stages that are involved in geophysical measurement or research. The first phase is geophysical data collection. You must first collect your data. For instance, we want to investigate why is inadequate water for a community. We must first understand the geology of that community. Having understood the geology of the community, then we must now embark on going to collect data. We have known our aim or our purpose, why we want to carry out that survey. Why is there that there is inadequate water supply in that area, or why is borehole in that area? Why is borehole
Recording
in
in
that area?
progress.
Why is borehole failing in that area? So, having understood or having identified the problem and stating our objective or our purpose, we now embark on data collection. We must first collect data. After we have collected the data, the next thing is we must interpret that data. We must process the data. That is the second stage. The last stage is how do we now use our knowledge of geophysics, of physics and geology to now interpret that data. So 3 stages are involved in any geophysical exercise. First stage is collection of data, data acquisition. The next stage is how do we process the data? The third stage is how do we interpret the data? Like I was saying, for 6 months, we spent 6 months just collecting the data according to plan. Just collect. After the 6 months, then the next stage of his work is processing the data. And behold, when he started processing the data, we started seeing some noisy data. In fact, the data became so noisy at the point that we could not process it again. I was very close to him. I assisted in processing the data as well. And at a point, we could not make something meaningful out of it because we know the aim and our aim and objectives. Because we have our aim and objective, we are expecting to see something which we are not seeing. So it became so worrisome that we keep processing, we are not seeing what we are expected to see. Then we have to involve our supervisor. He has to involve the supervisor. Involving the supervisor, he also requested that the data should be sent to him. The data were sent to him. He also processed and he was not seeing the results that we are expecting to see too. Then he has a colleague who is also an icon. When we mean an icon, you can't talk about electrical resistivity survey without mention. If you mention 3 persons, you must see what they call Locke. Locke was one of the father, is one of the father of electrical resistivity. In Nigeria here, we call him Loke. So it was when I had the opportunity of seeing him in Malaysia, and we told him jokingly that they used to call you Loke in Nigeria. He now laughed. Our supervisor sent the data to him. He also processed, and he was seeing what we are also seeing. But because it was more vast than any other person, he now asked, how much current did we inject into the ground? And that was where the problem is. So when our supervisor called my colleague that when you are collecting the data, check your survey parameter, how much current did you inject when you are collecting it at the landfill? And when he told him this is the current injected, our supervisor told him, he said, oh, that is where the problem is. That in that kind of noisy environment where so many rubbish, landfill, they call it rubbish, where rubbish is dumped, you don't inject that kind of current. So we use 30 milliamps. He said in that kind of environment, your current should not be less than 80 milliamps. Look at what the choice of using a wrong parameter, look at what it has caused. So he said in that kind of environment, your current should not be less than 60 or 80 milliamps. What we did for 6 months was rubbish. Our supervisor arranged for money again to assist my colleague. We have to go back. And he told us, do this, do this, do this. And we worked according to his instruction. Instead of 6 months, we did it for another 3 months. And by the time we now go to the processing stage, the results that we are expected, we start seeing them. For those that will remain in geophysics by God's grace, when you get to year 3, I will tell you some of that result if I'm going to teach you electrical resistivity. You will see what was obtained 6 months before, and you will see what was obtained after the proper survey parameters have been used. So if I'm going to teach you electrical resistivity when you get to year 3 by God's grace, you are going to see that every year that I teach, I always project the results to them. So you must equip yourself with the right survey parameter. You must equip yourself with the right parameter before you embark on geophysical survey. Otherwise, time, cost will be parted with. Look at how 6 months just went away like that as a waste, because my colleague did not use or chose the proper survey parameter before embarking on that survey. So it is essential that we need to understand, or we need to choose the proper survey parameter before we embark on geophysical survey. So that is very, very important. So it is, and like I said, that an acceptable survey design, a survey design that we can accept, should ensure acquisition of those data that best resolve specific subsurface feature. So those parameters that can resolve, we're going to talk about resolution as the class advances. So we must choose a parameter that will assist us to resolve the specific target feature. Like I said, a petrol tank or hydrocarbon tank is buried in the surface, and the size of that tank is about 30 meters. And by the time we want to use our survey, we are using a survey of 2 meters. We are separating our electrode at 2 meters. We are not going to see it because 2 meters is not adequate to see or to image an object or a target of 30 meters. Again, if we now decide to use a separation 1,000 meters, 1,000 meters is extremely too large for a target of 30 meters. So it is very important that we must ensure that proper survey parameters are chosen for us to resolve or to image specific subsurface feature or targets. Like I said, the goal is important because no amount of subsurface data processing, no amount of processing that we are going to do, if we miss that design, that survey design, no amount of processing we are going to do. It's just like what the computer people say, garbage in, garbage out. If you garbage in wrong parameter, what you get as your data processing is going to be garbage out. It's also going to be faulty. So it's very important that we give attention to survey parameter. Otherwise, those data that we need may be missing and we will not be able to resolve the appropriate target. So I will ask you to note that the goal is important because no amount of surface data processing or analysis can ever compensate for inadequate data. If inadequate, that is also part of what we are going to do. When you are embarked, you must ensure that adequate data are collected for us to investigate a particular site. So the data must be adequate, or missing data that could have contributed significantly to resolving geological targets. So the data that we need to resolve that target, if then there is no way we can make meaningful processing or interpretation. Appropriate survey design is therefore critical. Again, appropriate survey design is therefore critical to justify one, the cost of experiment. So if appropriate survey design is carried out, then it will enable us to justify the cost of the experiment or the survey. You can imagine if one has gone to rent that equipment, and renting equipment is capital intensive. By the time you are going to write your project, some of you guys will be lamenting by how much you are going to spend. I remember too, when I was doing my master's program, I have to go to Badagry to collect my data. As far back as in the 90s, and that was when I was doing my master's, I think precisely 2004. Only very few can boast of equipment we use for collecting resistivity data. In fact, the university is University of what's the name of this university? Federal University of something, Abeokuta, FUNAB. The man that was FUNAB was one of the few universities that can boast of equipment as far back as 2004. And when that equipment comes, all of us as master students, the man will draw a circle around us. He draw a circle around the equipment. We as students now crowd ourselves around that circle because he does not want us to touch the equipment. As sacred as he saw the equipment then, nobody there. He drew a circle, and all of us will be looking at the equipment when someone operates it. So when I wanted to go and collect my data, the present HOD of the department, the man entrusted the equipment to him that we should go and use the equipment because he was versatile with the use of the equipment. So instead of someone following us, the man entrusted the equipment to him. And we went to Badagry to collect the data. The first day, we had fair survey. The second day, it was troublesome. We couldn't collect it. We connect, it was not giving what we expected. The second day, the third day, and I have already paid for the equipment. So why the equipment was not functioning, I was looking at how much I was losing. And I am to use that equipment for 5 days or 6 days. 2 of these days, the equipment did not function. I became so nervous, agitating, and when it was a day before the last day, the man called, and the HOD, who we used to call Professor Adi, who is Professor Adi, he now told the man that for 2 days, the equipment did not function. And the man said, nothing concerns him. So it means for that 2 days, the money I paid for that Tuesday, the money is gone. And what happens? The last day, what the HOD did, he just took the courage, he switched off his phone so that the man will not be able to reach out to him, because the man is telling us that another client is waiting for that equipment to be used. I became so jittery that to finish that work. And what he did was he just switched off his phone so that the man will not have access to him, nor me. And we have to spend extra 2 days, pay for the hotel we stay. We have to pay extra day. I have to feed extra people and all. So you can now, it has cost me additional money for the acquisition. So appropriate survey design is therefore critical to justify the cost of the survey or experiment. So appropriate survey parameter must be robust for us to justify the cost of the experiment. It must be robust, number one. It must be accurate, accuracy too, and precision. It must be robust and precision of the recovered geological information. That target, it must also show some level of accuracy and precision together. Accuracy, how close the value that we have measured, how close is it to the true value? So we need to be precise. We need to show accuracy as well as robustness. All these parameters are necessary whenever we are embarking on geophysical survey. So you can see design parameter is very necessary when we are embarking on geophysical survey. So we can go back to the teaching material. So one of the most important aspects of a geophysical survey is the design of the coupling with the target we want to get in the subsurface. Sometimes by some that target is called an anomaly. That target sometimes is called, and by the time you get to the three, when you drive it to the other target, when the target is 30 meters, we are going to ASING. That is aliasing. When the object is there, our survey tells us that it is not there because we have chosen or we have used wrong parameter. So in order to detect the target, we must ensure optimum use of our survey parameter as well as the resolution. Therefore, it is important to and receiver. What receives the response? The transmitter is from the ground, from the surface of the ground. We send a signal into the ground. That signal will travel inside the when the signal gets to where the target, then it will modulate that signal and give another response. Another response is what's called receiver. So the response will now be picked up by another thing in the ground. That is called a receiver. So the sought target is before doing a geophysical survey. So there are some questions that are pertinent for us to ask when we are embarking on geophysical survey. What are these questions? In order to design an effective geophysical survey, that will influence the survey design, what are these questions? What am I looking for? I'm looking for a buried pipe in the subsurface. To what depth? How large is it? The tank is 30 meters. How deep is it buried? It's buried at about 40 or 50 meters beneath the surface. So you can see now, I need to ask myself, what am I actually looking for? Is someone has consulted us to come and carry out geophysical investigation. What we try to resolve as geophysicists or earth scientists. Something is in the ground. If you look, you cannot see it. But we are going to take a picture. We take a picture from the ground of what is beneath the ground. And that is why some people, they will say you are a winch. They will call you winch, or they will call you wizard. You will tell them that where you are standing, what is beneath where you are standing as geoscientists, and they will tell you, where is your camera? Your camera is the measurement you take, reveal what is inside the earth. What geology is in my area? You need to understand the geology area as well. With adequate geology, whatever you are seeing, you will be able to explain what it represents. Another question is there a particular direction to the geology? Whenever we are embarking on geophysical survey, if I go back to the second slide, if I go back to this slide, you can see solid lines, and you can as well see dotted lines. These solid and dotted lines, they are our survey lines, or what we call our pole lines. And here you can see two arrows. Can you see two arrows? These two arrows, can you see they seem to be perpendicular? So whenever we want to establish our survey lines, our survey lines must always be established perpendicular to what we call the geological strike. It must be perpendicular to geological strike, and that is what that arrow, if you look at the two arrows are perpendicular to that line that is like a dash or dotted line. How do you know the geological strike? You can make use of your inclinometer. You must buy as a geoscientist student. You must, I think every student must carry an inclinometer. So you use the inclinometer to know the direction. Sometimes we may not be able to know the direction of the geological strike. What we are going to do now is we are going to establish our survey line in such a way that you look at some trends. For instance, if you go to Badagry houses, Sultan Beach, when you go to Sultan Beach, when you are going to Semet, through Badagry and all that, you see the manner in which those coconut trees are lined. You see the path polo. Sometimes if you cannot establish a geological strike, you now look at pattern, look at all those coconut trees, look at the manner in which they are. So that can also assist us in establishing our survey line. Look at how those coconut trees, look at the pattern they obtain. You will now establish your line perpendicular to those patterns, to the pattern of those coconut tree. Or there is Lagos Lagoon. Lagos Lagoon is just behind us here. Before we carry out our investigation, before we start taking measurement, an essential thing we must do is what is called recognizance. We must do a recognizance survey to familiarize ourselves with that environment where we want to collect data. The geologist come and survey University of Lagos. We just don't come and start collecting geophysical data. One of the things we must do is to familiarize ourselves with University of Lagos. By the time we start moving now, we now get, there is a lagoon. With this lagoon, we have now identified a feature. So we are going to set up our survey line perpendicular to that lagoon. So it is essential that recognizance survey should always precede our data acquisition. We must do recognizance with the geology of that area. In fact, you just don't start collecting data. Let's say you want to start your data acquisition, that today, tomorrow, before that Saturday, you do a recognizance survey in order to familiarize your area. So before data collection, geophysical data collection, recognizance survey usually precede such exercise. So we can go back. So it is important to know, is there a particular direction to the geology? The direction we always emphasize is it must be perpendicular to the geological strike. Or you look at, if you cannot establish the geological strike with your inclinometer, then you look at some features in that neighborhood. And I've used, for instance, you go to Sultan Beach in Badagry, you started seeing those coconut trees, the way they are arranged. So features like that will enable or will help us to establish survey parameter or survey line. The next, what are the physical properties of my target property that we are interested in? What are these physical properties? We are talking about what are the physical parameters we want to measure? We want to measure resistivity. Resistivity is one of the physical parameters. Density parameter. Velocity is one of the physical parameters. Permittivity is one process with what are the physical parameters of my target. What am I actually interested in? It is that sorry again, the network signed us out. So the physical parameter that we are interested in measuring, having information about these physical parameters too, they are very important. We must know what are the physical parameters. For instance, we want to carry out a survey using electrical resistivity method. Once we have the physical parameter, the work of a geophysicist stops. For geophysicists, once you start getting the physical parameter that can be associated with that target, your work as a geophysicist stops. Having obtained the physical parameter, It is then that those who are well equipped with, who are well grounded in geology, that is when their work can now commence. Having understood or measured the physical parameter, you will now transfer those physical parameters to those in the geological section. With those physical parameters and the geology they know, they can now start interpreting. So you can now see how the three stages that are involved in geophysical exercise, how they have come to play. First, you must carry data acquisition, which is data collection. After the data collection, you must process the data. When you process the data, you want to get physical property. After you have measured that area, can now be interpreted. When the geology and the physical parameter are used for interpretation, then the third stage is now being done. Having obtained the physical parameter and the geology, then recommendation can be made. So, what are the physical properties of my target and their other units, and how do they impact my survey? Is there input contrast between the physical parameters? This question, for us to use a particular method, for instance, I want to use gravity method as one of the tools for prospecting. I want to make use of gravity method. For me to use gravity method in prospecting, I must be looking for what we call density contrast. There must be density contrast between the target, between what is my target or anomaly. There must be density contrast between the anomaly and what is surrounding the anomaly. So if there is a contrast between the target and the anomaly, that contrast can now tell us that gravity method can be used. So if there is no contrast, then we can't use gravity method. So another thing that can show how effective a geophysics is there going to be a good contrast in property? For instance, I want to make use of electric resistivity method. There must be a good contrast between the conductivity of the target and the conductivity of the surrounding, or what is hosting the target. If the target and the surrounding, if they have the same property, physical property, if there is no difference in their conductivity, then I'm going to leave that method. That method can no longer or cannot be used. There must be a discriminating feature. There must be contrast between the two materials. That contrast is what will make that method suitable. Do I need a 2D survey or a 3D survey? 2D survey is two-dimensional survey. We want to carry out measurement in 2 dimensions. Like this laptop, my laptop or your own laptop you are using, it has a wider part, which we can say is x-axis, and the other part, which is the y-axis. So anything I'm seeing in my laptop is in 2 dimensions. But sometimes that may not be enough. Sometimes we want to see every aspect of that target. For us to see every aspect of that target, we have to talk about a 3-dimensional survey. A 3-dimensional survey reveals everything about the object. We can see the top, we can see the front, we can see that is what a 3D does. A 2D only tells us something about the front and something about the side. So again, whether we are going to use 1D, 2D, or 3D, will also depend on the purpose why we are embarking on that survey. When we use 2D survey, we are not going to get enough information as when we use 3D survey. 3D survey will tell us more about that object, and that is what you see. Some of us, we go to cinema hall, we go and watch movie and in 3D. 3D, you have to wear that goggle in order for you to see every aspect of that object that is in 3D, and you see how fascinating that can be. If you are not wearing anything, what you are seeing is in 2D. Anything you see from your laptop is in 2D, or from your phone is in 2D. For you to see behind the back of that object, then you have to go on 3D. So if we are going to embark on 2D survey, we should know the limitation of 2D. Information 2D gives cannot be as accurate or cannot be as adequate as when we embark on 3D survey. 3D survey, in fact, tells us the whole aspect. And aside the 3D, we also have 4D now, where we have to carry out survey with respect to time. How much can I spend on my survey is another thing. The time and money, all these are necessary. Now let us look at detectability. How do we detect a target? How do we image or detect a target? How do we image or how do we detect a target or anomaly? In order for a target to be detectable, before we can detect or map a target, now I've been specific now. The secondary feed, whether that can be electric, it can be electric field or magnetic field or voltage potential. These are the, depending on the method we are using, they will tell us what kind of field we are going to have. Must be larger than the noise or geological noise or instrument noise. So it is essential that in order for a target to be detectable, the secondary field, whether that be the electric field or magnetic field or voltage potential, must be larger than the noise or geological noise or instrument that must be associated with. What do we call secondary field? Let me sign out now and go to the whiteboard so that you can have an understanding of what secondary field is. So I'll go to the whiteboard now. Okay, so let's see. So if this is the ground surface now, this represents the ground surface. This is a active body. This is a target in the subsurface. This is the target that we want to map. There is a transmitter. This is the transmitter which is placed on the ground surface. TS represents transmitter. And there is a receiver here. RS represents a receiver. I want to make use of electromagnetic method. Electromagnetic method is another method that we use in geophysical prospecting. The Faraday law, you know, in your physics when you were in secondary school. That is how we make use of Faraday's law here. Now, from the transmitter, this is the transmitter. CR, we call it transmitter. Again, when you get to year 3, you will do this in detail. Transmitter. This is the transmitter, we call it TS, and this is the receiver, RS. As the name implies, it receives signal. Transmitter transmits signal, receiver receives signal. Now from the transmitter, if a signal is sent into the ground this way, from the transmitter, a signal is sent into the ground this way. This signal that is sent into the ground, we call it the primary feed. This is called primary feed. This signal from the transmitter that goes to the target, we call it primary feed. It is called primary feed. When the signal gets to the target, it will change that feed to current, and from there, what goes from the target to the receiver is what we call the receiver's, the secondary feed. This is called the secondary feed. This is the secondary feed. So we know where the primary feed is coming from and where the secondary feed is also coming from. So the secondary feed is that feed that is coming from the target to the receiver. That is a definition of secondary feed. The feed that comes from the target to the receiver, where the primary feed is the feed that comes from the transmitter that gets to the target. So the secondary feed must be very, very large. To this target, we could associate some noise with it. There could be some noise, which is what we call in physics, we call it eddy current, unwanted current. So because this transmitter gives current to this target, there could be some part that is not useful. That part that is not useful will give us noise. So there will be noise here, which is unwanted. Noise is unwanted signal. Noise is unwanted signal. So noise is the unwanted signal. So what are we saying? The secondary feed must be very, very large compared to the unwanted signal. I hope you understand what that means now. So I've just used this diagram to illustrate what do we call secondary feed and what do we call primary feed, and what is noise, which is unwanted signal. So the signal that comes from the transmitter that gets into the subsurface will produce a primary feed. The primary feed will be converted to eddy current, which is usually unwanted, and the other current will now get to the receiver, which is called the secondary feed. So we go out again. So I hope you understand that. So I want to go back to the slide now. So in order for a target to be detectable, that diagram that I drew, the secondary feed, you know what the secondary feed is now, must be larger than the noise. The noise is geological noise or instrumental noise. it must be relatively large enough compared to the primary feed. You know what primary feed represents as well. The signal that is coming from the transmitter that gets to the target is the primary feed. So the secondary feed must be large enough compared to the primary. For example, if the noise in the primary feed is anticipated to be 5% and the instrument sensitivity is 5 millivolts, then the secondary feed must be least be above 5 millivolts. It must be least be above. It must be above 5 or at least it is 5 volts to be detectable, but also more than 5% difference compared to the primary feed. And how do we do that? This provides us with two metrics for measurement. What are these two metrics? What do we call relative difference and absolute difference? In the next class, we are going to look at these two, and I will use that to round up my class with you. So if you have any question, feel free to let me know. So we are going to look at relative difference and absolute difference. How do we measure relative difference in terms of the secondary feed, in terms of the primary feed, in terms of the total feed? So we are going to look at that in the next class. If you have any question, kindly feel free to ask me.
Well, now when class finish, I'll enter class. Jesus.
You said? I hear you. I can't hear you, please. Can you come again, please? Oh, it's breaking. Oh, that line is breaking. Can you type the question, please?
Sir.
Can you type the question? Yes?
Sir. He actually meant that what if we don't know our target?
This voice is better. Yes, this is better. I think it should be his network. Yeah, you can go ahead.
He actually meant that.
I can hear you now. It's better with your own.
I hear me, sir.
I can't hear you too. I can't hear you. Okay. Yeah, okay. Can you go ahead now?
Okay. It meant that what if we don't know our target? We don't know
where our target is. Can you go ahead with the question?
That's what I'm still saying.
What you don't know about your target?
Like we don't know where it is.
Yes, know your target, but
then how will we send the wave?
You don't know where it is under the ground.
Yes, sir.
You need not to know you need not to know where your target is. So that is why you are going to embark on geophysical survey. But you can't just go to any land, any site that you want to investigate. There must be someone that must know history of that site that should be able to tell you something. For instance, we are going to a place where those who have known those people that have lived in that area, they believe that when they were many years back, they were used to some artifacts, historical artifacts. Because someone has told us that the part of what they like are artifacts, that will give us an indication that they may likely like iron materials or that. So you still need someone to give you some information about that site. You just don't go to any site without any guide. If you go there without any guide, the problems that we are talking, those problems will surface or they will arise. So you need someone to provide an information. Is that information that will guide us on where that target is? Yes, you are correct. What about situation where we don't know if the target is there? If we don't know, our geophysical survey will tell us if the target is there or the target is not there. Though we are going to have some difficulty because we won't be able to design the most appropriate survey parameter. But if our survey parameter are chosen in such a manner that they can tell us where that target is, we will see it in our results. So essentially, for us to have information about that site, for us to know the geology of that site is very necessary, rather than embarking on a site that we do not have any information. There is no one that can give information about that place. No, there must be someone that knows that issue. When you go to a community, you have to go and see the elders in the community. They will now tell you so person can give so information. So in every community, you have those that can provide information about that community. These are the people you must go and see during your recognizance of that they can give information about that place. It is extremely rare for you to see a place where they will tell you there is nobody that has information. Some live, some passed on. Before they passed on, they must have information and sustained. So when you get to a community, the first thing is go and see those elders in the community. They can start telling you when you are going to year 2, when you get to year 2, the first time you get to Abeokuta, if you are going to be going to Abeokuta, usually we go to Oyo State or other places, but because of this issue of kidnapping and what have you, your trip has been restricted only to Abeokuta. The first day you get to Abeokuta, before you can start your mapping, the first thing you do is to go and see the community people. They will now start telling you about that community. So you need information about that community. I just want to emphasize on the fact that getting little information about that place you want to carry out your survey is very, very necessary, and we guide you on how the survey can be carried out. I hope that is clear. Any
Yes,
other
sir.
question? Go ahead. If there is any other question, can you go ahead?
Okay, good morning, sir.
Yeah, how are you?
Can you?
Yeah, I can hear you.
Okay, sir, I wanted to ask whether there is a specific distance that was supposed to be the transmitter and the receiver.
Yes, like the one I drew, depending on the instrument you are going to use. We have some that are 10 meters between the receiver and the transmitter. Some will be 10 meters, some will be 20 meters, some will be 40 meters. In that, when you get to year 3 is when you are going to start the survey proper. When you get to year 3, I'm talking about the EM method, you will see some separation at 10, we have some separation at 20, we have another separation at 40. And that separation of 20 will not get to the same depth as 10. The separation of 40 will not also detect the same object as that of 10. So depth and separation, both of them are very important whenever we are embarking on survey.
Okay, sir. Thank you, sir.
Any other question? Okay. Any more? Okay, I think this is on a fine place we can end the class. You will get the material, though I will still be updating it, but I think I will send this material so that you can read more. Okay, enjoy the rest of your day. I'll also send the recorded lecture as well.